Hi, have you ever wondered how use memo works from React? Well, it has a concept called memoization where we cache the result of a function. So think of it this way. If we have like a very complex function that does 4 inside 4, some math equations, maybe some recursive functions as well. Well, if you have this in multiple places in the app, you don't want to run it multiple times. What you want to do is you want to cache the result based on the arguments. So let's first write some tests to see how this would work. So imagine we have our memoization basic function. We wrap it inside of our memoize implementation, and then we write some basic test. If we call it with some arguments and we call it with the same arguments, we want it to run only once. But if we change the arguments, it should run twice. So let's run this now. And of course, it's going to fail because we don't have any function implemented. Let's do that first. So imagine this is our memoization function. It takes a function as an argument. And then it's going to first, we need a cache where we set our closure, and then we return a function. What is our function going to do? Well, first is going to create keys out of the arguments. We're going to use JSON stringify here, and then we're going to check the cache. Do we have a value for these keys? If we do, we return it. If we don't, we're going to actually run the function and get the result, and then set the result inside of the cache and return the result. So this is the basic implementation of a memoization function. As you can see, very, very simple. And then if we run our tests, as you can see, they are going to pass. So there you have it, a very simple implementation. But use memo is way, way more complicated. So we want to handle that complexity as well. As you can tell, JSON stringify and map are not really good options to use once we added more tests. So let's think about other use cases that our memoization function has to handle. First, what if we have objects as arguments? And what if these objects are the same, but with the keys in different order? Our map and our stringify are not gonna work well with this use case. So then let's think of another use case. What if instead of objects, we actually have symbols? Symbols are very popular in JavaScript. You can use them for different things. So if we're using symbols, our map implementation is also not going to work. So let's try with a different type of type as well. So imagine now we are passing actually, what can we pass to test for? Let's see, let's pass maps. If we pass different maps, as you can see, they are actually different objects because even if we use the same arguments inside of the map. So we want it to be called 2 times when we run our memoization function. But if we run our memoization function on the first map, it should be called just once. So it stays at 2 because we're not resetting the spy here. What else? We can actually check for functions inside of arguments. So imagine we have 2 functions. We call memoization on the first function. We expect it to be called once. If we call it again, we again expect it to be called once. And if we call it the second time, even though the functions do the same thing, we need it to be called twice for it to work correctly. Then in JavaScript, you can have circular references. So imagine we have circular1, our object, with a self value inside the empty objects, and then we set it back to the circular1 value because JavaScript passes value by reference. This will work. It will create a circular reference, as we call it. Let's do it again for a second object. And then if we memoize circular1, we call the function. It should be work twice. If we call it again, the cache should hit, so that should work fine. But then if we use the second circular2, it should not call the cache. And then finally, what's most important is we need to preserve the this context. So imagine here we have value 42 and a method that computes it based on the value. It's going to use this.value and then our memoized function. So once we run the memoized function with, let's say, the value 8, we expect it to run once. And if we run it again, again, we expect it to be run once, and we can even check the value that this is actually working. So there you have it, a lot of tests. If we run these, they are going to fail right now, but let's start implementing them. So first we need our generate key to be much more complex than a simple JSON stringify. So what are we gonna do? First, we're gonna map through the arguments. We're gonna check if they are null or undefined and just return null or undefined as string. And then finally, we're gonna see if any of them are objects. If they are, we're gonna check for the keys and sort them. That way we keep the order of the objects. And then we return a string that's based on the maps of the keys. And then finally we return a string of all of this big string that we have created and join all of them together in case we have multiple values. So now if we run it, you will see that 4 have passed. So we've fixed 2 issues, different arguments and object arguments with different orders. But we need something more complex. So for example, we need to check all of the type we have as arguments. So we're going to create a switch function and we're going to say, okay, if it's a string, we return the value. If it's a number of Boolean, we transform it into a string. If it's a symbol, we create a string called symbol. So we're going to use the symbol as a key. The same we're going to do with function. We get the function name, or we say anonymous for if it's an anonymous function. If it's an object, we do something more complex where we create a map of all of the keys and then we generate a key for the value. So we do what we did first time. If it's a set, we do the same thing. We add some complex logic to create the key. And then if it's array, we do the same. And for regular objects, we just return the keys and generate a key for each value of the key and join them together. The default is going to be a string value. And we're going to use this generate key function inside of our generate key big function. So we're going to use it right here. Let's delete what we had before. So instead, we're going to first check if there's length 0, length 1, and then we generate a key for all of this. So now, if we run our function, well, almost there. 5 have passed. We still have some problems, namely symbols are not working. Maps are not working, and the circular reference is still not working. So let's fix that. Let's change a little bit how our memoization function works. We actually need to break it down into 2 caches. The primitive cache that handles primitive, we can use a map, but for everything more complex, we need a weak map that handles more complex logic. So now we first check the argument length. If it's 1, we take the 0 one, we check if the argument is a symbol. If it is, we put the values inside of the primitive cache. We handle there all of our values, and then for if it's an object or it's a function, we use the cache that is a weak map, and we do the same logic as we had before. So first we check the cache, we set the value inside of the cache, and then we return the value from the cache if it's there. If it's not there, we generate a key, we check if the primitive cache has the key, and then we apply the function if it doesn't and set it inside of the cache. So this is a much more complex option. And now if we run our test, you can see only one test is failing right now, which is that the property orders are no longer working that we fixed initially. So let's get this to work as well. So you can see here where we are checking for an object or a function, we actually need to do something more complex. First, we need to check map, set, and the function, and we have the same values as before. But for regular objects, we need to handle it differently, and we need to bring back the options where we use the primitive cache because that one was working for objects. So now when we run the tests, nice, 7 are passing. Just one more thing we need to handle, and that is circular reference. So when we have circular reference, we need to actually check for it because otherwise we get lost. So let's create a function has circular reference. It takes a value, which can be anything, and then we check if the value has already a value, we return true, and then we loop through the keys of the object and we apply a recursive value, so we check it again, and then we use this here inside if it's a function or if it has circular reference. So now we're checking for all circular references and we apply the same logic as before. And if we run our test, everything is passing. So success for us. And as you can imagine, this is not actually production ready code. It's actually what you need to handle during an interview. So here we handle all sorts of edge cases that you can showcase your JavaScript knowledge. And you can actually see now how complex useMemo actually is. useMemo actually has two functions that work inside of each other. And yes, thank you for watching, like and subscribe, and welcome to my channel.